this video, we are going to look at using exact values from our unit circle to evaluate expressions and solve equations. From our unit circle, we definitely need to have all of our values memorized, at least in quadrant 1, for sine, cosine, and tangent. So to evaluate, looking at something like sine of pi over 4, we know that in quadrant 1, sine for this angle, the ratio is equal to square root of 2 over 2. Also in quadrant 1, we have pi over 6. Cosine of pi over 6 from our unit circle is equal to root 3 over 2. When you combine these, the only way you can combine fractions is if you have a common denominator, which we have. So our denominator is 2, but our radicals in the numerator are unlike radicals, so they do need to remain separate. In our second example, cosecant is a reciprocal function to sine. So we can look at cosecant in terms of sine, and then we're going to take the reciprocal of its answer. So sine of 3 pi over 2 is -1. The reciprocal for -1 is also -1. This means that you are multiplying 2 times what you get for tangent of 5 pi over 4. The tangent of 5 pi over 4, tangent are angles in quadrant 3, tangent's positive in quadrant 3, and this has a value of 1. Combining this, our final answer is -3. Knowing all of your stuff on the unit circle is a must. These two examples, the first one, seeing that cotangent is multiplied by secant. Cotangent and secant are both reciprocal functions. Cotangent, we can evaluate tangent. In quadrant 1, tangent is radical 3, so the cotangent is radical 3 over 3. That will get multiplied by the secant is 7 pi over 6, which is equivalent to the reciprocal of cosine of 7 pi over 6. If we evaluate cosine, we take the reciprocal. So we're in quadrant 3. Again, cosine is negative. Cosine is root 3 over 2. Therefore, this comes out to be 2 root 3 over 3 negative. Okay. Sine of 11 pi over 6, that is going to be in quadrant 4. Sine of pi over 6 is 1/2, so in quadrant 4, this becomes -1/2. Putting all of this together, this numerator multiply, we end up with -6, right? 3 times 2 over 9 plus 1/2. Get a common denominator. We can change this to 18ths. I'm actually going to reduce this one. Reduce this to be 2 over 3. So we can have terms of sixths. And this whole answer comes out to be -1/6. This is 6 is 3/6. This and 6 is 4/6. So -4 minus 3 is -1/6. All right, so number 4, tangent pi over 6 and divided by 2. And then we have 1 over the secant of pi over 3. Tangent of pi over 6 in quadrant 1 is equivalent to radical 3 over 3, which I'm going to divide that by 2. This expression, 1 over the secant, is equivalent to cosine of pi over 3. So let's evaluate that instead, since they are the same. And I'm going to simplify the first fraction. We get radical 3 over 6, right? Keep change flip. And then we're going to subtract cosine of root 3 over 2 is a value of 1/2 pi over 3. Changing this common denominator, change this to 6, this is 3. When we combine this as one expression, we end up with a square root of 3 minus 3. Can't combine those, and leave it all over 6, and you are completely simplified. Right, so evaluating expressions, again, the better you know your unit circle, because you will not have your calculator, the better and easier a lot of this solving will be. Okay, so let's change direction a little bit and look at some equations and using our exact values to find equations. We are looking for all the angles that make the equation true between 0 and 2 pi. So we're looking for one continuous, all 4 quadrants, 1, 2, 3, and 4. So when we look at something that's saying sine of theta is equal to -1/2, what we're really saying is, okay, in quadrants 1, 2, 3, and 4, first of all, where is sine negative? And we are negative in quadrant 3 and quadrant 4. So that means we're actually going to have two answers. So where is sine equal to -1/2? Now we're going to look for where, what angles, what reference angle is equivalent or makes sine equal 1/2. And that, in this case, our reference angle is equal to 30 degrees or pi over 6. We are in radians for our interval, so we're going to be looking at pi over 6. So in quadrant 3, if our reference angle is pi over 6, that means our quadrant 3 angle is equal to 7 pi over 6. Our quadrant 4 angle is equal to then 11 pi over 6. Right, reference angle, again, we're adding to pi and we're subtracting 2 pi. So here our final answer for theta is equal to 7 pi over 6 and 11 pi over 6. In our next example, now we're looking at cosine. Cosine's √3/2. So we're first going to ask ourselves, where is cosine positive? Well, that's in quadrant 1 because everything's positive in quadrant 1. And cosine is also positive in quadrant 4. So we are going to have two answers for this one as well. So what is the reference angle that we get √3/2 for cosine? Our reference angle for this one is also pi over 6. So our two angles, and as another option, if you want to see the visual, we are looking at quadrant 1 angle with a reference angle of pi over 6, and we're looking for the quadrant 4 angle with a reference angle of pi over 6. That's what we're looking for. So our theta in quadrant 1 is pi over 6. Right, this one's pi over 6, and we're going down here, we're going all the way around to 2 pi, so this one is 11 pi over 6. Sometimes the visual helps, sometimes it helps just to write out. I gave you two examples of both methods. Let's look at another example where cotangent is equal to -√3. First, let's consider what quadrants we're talking about. We're looking for quadrants where tangent is negative. So tangent's negative in quadrant 2 and quadrant 4. So cotangent follows the same positive negative tangent. So reference angle gives us a value of radical 3 for tangent, and that is pi over 6. So we're looking for the tangent for positive. Tangent pi over 6, make it equivalent for tangent, right, is √3/3. So that's one angle, that's in quadrant 2, angle 4 pi over 6. We are going to take pi and subtract pi over 6. So one of the angles is equal to 5 pi over 6. And another option is quadrant 4. So we take 2 pi, subtract our reference angle, and we end up with, again, another 11 pi over 6. So our angles for tangent are going to, or cotangent, I mean, are going to be 5 pi over 6 and 11 pi over 6. Okay, so a third example, just adding and subtracting pi or 2 pi is another option to get your angles. Okay, the last example for this type of question, first you need to divide. You can't evaluate a trig function unless it is all by itself. So we really want to evaluate the tangent where it is -1. So you must divide first. So now we're looking for where's this positive? I'm sorry, negative. And tangent's negative in quadrant 2 and quadrant 4. What's your reference angle? And it is pi over 4. So reference angle in quadrant 2, again, I'll just draw a picture for this one. Your reference angle here is pi over 4 in quadrant 2. That means that theta in quadrant 2 is actually 3 pi over 4. And our other angle down here, if this is pi over 4, then we know that our other angle has to be 7 pi over 4. Again, our interval was from 0 to 2 pi, so we're only looking for the positive angles, not the negative ones.